Write down problem. The transfer function of discrete time causal system is given by h of z is equal to 1 minus z inverse divided by 1 minus zero point 0.2 z inverse minus 0.15 z raised to minus 2. Draw parallel realization. Parallel realization. Solution. So we know in parallel realization, we can adjust this transfer function h of z in the form of h1z plus h2 of z plus h3 of z and so on. Okay. So this h1z, h2 of z depends upon the power of h of z. Okay. So here the power of h of z, maximum power, the highest power of h of z is 2. That's why it requires only h1z and h2 of z. Correct. Now here you can adjust in the form of plus h1z plus h2 of z. How? How? By using h1z is adjusted in the form of h1z plus h2 of z using partial fraction method. So it's very simple and we know the partial fraction method. So in partial fraction method, either you convert the power from negative to positive. First convert the power of h of z into positive. Correct. So how to convert the power into positive? So multiply both numerator and denominator by highest power. And here the highest power is 2. That's why multiply numerator and denominator by z square. Okay. So this h of z becomes is equal to z square inside bracket 1 minus z inverse divided by z square inside bracket 1 minus 0.2 z inverse minus 0.15 z raised to minus 2. Okay, like this. So multiply numerator and denominator by z square. So it becomes h of z is equal to z square minus z divided by z square minus 0.2 Z minus 0.15 minus 0.15. So we solved the example in Z transform. How to find out the inverse Z transform by using partial fraction method. Correct? So here the thumb rule to find out the inverse Z transform, you arrange this h of z in the form of h of z divided by z. H of z divided by z. Correct? And therefore, you take z common from the numerator side and shift to the left side. Then it becomes h of z divided by z is equal to z minus 1 divided by z square minus 0.2z minus 0.15 minus 0.15 like this. Now here you find out the roots of a denominator, So whose the two numbers whose multiplication is minus 0.15 and addition is minus 0.2. Addition is minus 0.2. So these two numbers are, or by if you
0.5.
Not able to find out directly these two numbers, then we know the formula to find out the roots, that is minus b plus minus under root of b square minus 4ac divided by twice of a. So here a is 1 for this, for the denominator. A is 1, b is minus 0.2 and c is minus 0.15. C is minus 0.15. So by using that one, you can find out the two numbers whose multiplication is minus 0.15 and addition is minus 0.2. Okay. So these two numbers are 0.5 and 0.3. 0.5 and 0.3. Now multiplication require negative and addition require also negative. So if you consider the highest number is 0.5 as a negative and lowest number 0.3 as positive, then their multiplication is minus 0.15 and addition is minus 0.2. Addition is minus 0.2. So these two numbers are there. Then you can write it as h of z upon z is equal to z minus 1 divided by z minus 0.5 into z plus 0.3 into z plus 0.3. Okay. Now we can arrange this equation by taking the constant a1 and a2. So h of z upon z is equal to z minus 1 upon z minus 0.5 z plus 0.3 is equal to a1 divided by z minus 0.5 plus a2 divided by z plus 0.3. Now if you see, we want this h of z in the form of h1z plus h2 of z. h1z plus h2 of z. And if you observe this, it is in the form of a1 z minus 0.5 plus a2 z plus 0.3. Now this is your h1z and this is your h2 of z. Now it is in the form of h1z plus h2 of z. That's why in parallel realization you need to apply partial fraction method. Make it star and write the sentence. In parallel form realization, it is necessary to apply partial fraction method to arrange h of z in the form of h1z plus h2 of z. Okay. Now find out the constants. Here again I write this h of z upon z is equal to a1 divided by z minus 0.5 plus a2 divided by z plus 0.3. Z plus 0.3. So how to find out A1 and A2? A1 is equal to multiply this h of z upon z by z minus 0.5, its denominator, into z minus 1 divided by z minus 0.5 into z plus 0.3. For that z is equal to 0.5. So you equate this z minus 0.5 is equal to 0, then z becomes 0.5. So here this z minus 0.5, z minus 0.5 get cancelled, and remaining is z minus 1 upon z plus 0.3. So you put z is equal to 0.5 and then a1 value becomes, it should be minus 0.625. You try to find out it. This one is a1. Okay. Now in same way, a2 is equal to, its denominator is z plus 0.3 into h of z upon z is z minus 1 divided by z minus 0.5 into z plus 0.3. Okay, and for that value of z is, so you equate it is equal to 0, and then z becomes minus 0.3. Z becomes minus 0.3. So this z plus 0.3 get cancelled. Remaining is z minus 1 upon z minus 0.5. Put the value of z is minus 0.3, then you will get a of 2 is equal to 1.625. 1.625. So this is a1 and this is a2. A1 and a2. Okay. Now put these values, you call it as equation number 1. So put value of a1 and a2 in equation number 1, then your h of z upon z becomes, a1 is minus 0.625 divided by z minus 0.5 plus a2 is 1.625 divided by z plus 0.3. Okay, clear? Now you can shift this h of z upon z, this denominator of z, to the right side. Then a plain h of z becomes, h of z is equal to minus 0.625 of z divided by z minus 0.5 plus 1.625 z divided by z plus 0.3. So here I shift this z to the right side. Then h of z becomes these terms. Now it is in the form of, if you see, this one is h1z and this one is H2 of Z. H1Z and H2 of Z. Now it is in the form of H1Z plus H2 of Z. H1Z plus H2 of Z. So here H1Z and H2 of Z both realize using direct form 2. Both realize using direct form 2 only, not direct form 1, direct form 2. So in cascade and parallel, realization of H1 and H2 of Z or H3 of Z using direct form second, not direct form first. So direct form second. Now here we know to apply direct form first or direct form second, the power of Z should be negative. Power of Z should be negative. So arrange, first we consider H1Z. So H1Z is equal to minus 0.625 of Z divided by Z minus 0.5. Z minus 0.5. And here H2 of Z is equal to 1.625 Z divided by Z plus 0.3. Divided by Z plus 0.3. ठीक है. Now adjust the power in negative. How? So take common the highest power from numerator and denominator. So highest power, here it is 1, here it is 1. So you take Z common from the numerator and denominator. So it becomes H1Z is equal to Z common inside bracket minus 0.625 only divided by Z common 1 minus 0.5 Z inverse. Okay, this Z and Z get cancelled. Now this H1Z becomes minus 0.625 divided by 1 minus 0.5 Z inverse. Now it is in the form of negative power. Same way for H2 of Z, the highest power at the numerator is 1, at the denominator is also 1. That's why you take Z common. So H2 of Z is equal to Z common inside bracket 1.625 divided by Z common 1 plus 0.3 Z inverse. 1 plus 0.3 Z inverse. Z get cancelled and then H2 of Z is equal to 1.625 divided by 1 plus 0.3 Z inverse. 1 plus 0.3 Z inverse. Okay. Now it is in the form of negative power, and then it is very simple to apply the direct form to the shortcut method. Okay. So in shortcut method, see the highest power at the numerator and denominator, the highest power is 1. That's why it require only one delay. It require only one delay. So here first draw that delay. Then at the left side, you consider the denominator. So this denominator having the term as Z inverse with a constant minus 0.5. With constant minus 0.5. So you change the sign and draw it with plus 0.5. Plus 0.5. Okay. And then it is added here like this, and here the constant is 1. That's why it is 1 here. It is 1 like this. Okay, so this is denominator, means the left side, and at the right side you draw for the zeros, means the numerator having only one constant, and that is nothing but minus 0.625. So it becomes minus 0.625. Minus 0.625 like this one. This is the realization of H1Z using direct form second. Correct. So in same way for H2 of Z, in this case the highest power is again 1 at the numerator and denominator. Highest power is 1. That's why it requires only one delay, like this, z raised to -1, correct? Then at the left side, you draw the structure for denominator, means the poles. Here the constant with z inverse is plus 0.3. That's why it becomes minus 0.3. It get added here. The constant is one direction of arrow, like this, correct? And at the right side, you consider numerator, means the poles, it having only one constant, that is 1.625. That is 1.625. So this is H1Z and this is H2 of Z. H1Z and H2 of Z. So in parallel form, addition is there. Addition is there. And as the name indicate, it is parallel structure. It is parallel structure. That's why you can draw the H1Z and H2 of Z in parallel manner. So here it is H1Z, here it is H2 of Z, and both get added here like this. This is input X of n and this is output Y of n. So like this you can arrange the H1Z and H2 of Z in parallel manner and get added. Okay. So here, due to the limited space, here I draw the parallel structure of this H1Z and H2 of Z. So how? First at the upper side you draw H1Z. So H1Z as it is. Here the delay Z inverse, constant is 0.5, like this, and here it is minus 0.625, minus 0.625, correct? This is H1Z. Below that you draw the H2 of Z plus, here it is delay Z inverse, here a constant that is minus 0.3, and this one is 1, this one is 1.625, like this. Okay, so one below 1 you draw the H1Z and H2 of Z and then connect it only. So this one is connected to this one. You called it as an input, so called it as X of n, and the output get added. So this one is get added here, this one is get added here, and you called it as output Y of n, like this one. And this is called as a parallel structure, parallel realization. This is called as parallel realization.